So next we're going to talk about something called piecewise functions. So piecewise functions are just how to make a function out of pieces. Okay, that's where the name comes from. So if we look at piecewise functions, this is what they look like. Not like that. Nice try. This is what they look like. F of x equals, and then we have a really big brace, a really big curly bracket. And then we just have different formulas. So we might use one formula. Maybe we'll call it formula 1 if x is in domain 1. And then maybe we use another formula, which is written right below it, if x is in domain 2. And this can continue on for as many as we want. You can literally have an infinite number of formulas in your piecewise functions. So that's the abstract kind of definition, but let's actually look at something and piece things together. Example 5, okay? Let's look at a real piecewise function. Let f of x equal piecewise function. Sometimes we use the formula negative x. Sometimes we use the formula x squared. And sometimes we use the formula x plus 1. How do we know which formula to use? It depends on where in the domain we are. So if x is less than negative 2, we use the first formula. If x is between negative 2 and 0, we use the second formula. And if x is bigger than or equal to 0, we use the third formula. So that's how it translates, right? We have 3 formulas, and to decide which formula we use, because we're only using one, right? It's a function. There should only be one output. This is how we decide which one to use. So let's find some values. Part A, find f of negative 3. So what's our x value here? Right here, x is negative 3. So which piece do we use? X is negative 3. Which interval does that lie on? Well, negative 3, that's this piece, to the left of negative 2. And if you want, you can maybe draw these on the number line and see which one of these has negative 3. Okay? And let's label these pieces. You don't have to label these or number these, but you can. So x equals negative 3. So that's piece 1. We're using this formula. So what is that formula? That formula says whatever x is, we're using negative x. So we're plugging in negative 3 into this formula. We're using formula 1 here because that's where our x value is in the domain. So f of negative 3 is positive 3. Let's do another one. Let's look at f of negative 2. So again, we look at our x value. Our x value is x equals negative 2. Which piece is that in? It's going to be this piece, right? This is the piece between negative 2 and including negative 2 and 0. So we're going to use piece number 2. So we plug in negative 2 into this piece. All right. So f of negative 2 is negative 2 squared. Just plugging it in to the formula that is in the right piece. Make sure to have parentheses. Negative 2 times negative 2 is positive 4. Let's do a couple more up here. So it's all on the same page. F of negative 1. Again, what's our x value here? Here, x is negative 1. We have to look at our pieces and say, negative 1 is in which interval? Negative 1 is in this interval. Okay, so again, we're going to use the second piece. So plug this into the second piece. And again, it's negative 1 squared. Square negative 1, you get positive 1. Try to do this with the next two. F of 0 and f of positive 1. Pause the video and let me know what you get. So 0, this is going to be piece 3. Greater than or equal to 0. Because this one includes 0. We plug it into this formula, x plus 1. Replace x with 0, and we get f of 0 equals positive 1. Here, we have x equals 1. X equals 1 is this piece, because 1 is also to the right of 0. So we plug it into this formula, 1 plus 1. Oh, that's the wrong color. F of 1 equals positive 2. And piecewise functions can cause a lot of trouble, a lot of tricks. We'll be using them more later in this video, and we have extra problems in 325. This is 324. Let's do some more with this, shall we? Example 6. Let's go the other way. A museum charges $5 per person. That's the worst dollar sign I've ever seen in my life. $5 per person for a tour with 1 to 9 people. Or they also charge a flat $50 fee for a tour of 10 or more people. Okay, so they'll charge per person if it's a small group, and then just give you a flat fee if you want a tour for a big group. All right. The question is, write a function relating the number of people n who want a tour. Whoa. Number of people n who want a tour to the total cost, capital C. So we need a piecewise function here. And the reason why we need a piecewise function is there are different rules. Different rules apply depending on the situation. It's either $5 per person or $50 total. And so that's how we're going to kind of start right here. This function, right, the cost is a function of n, right? Usually we write f of x. You can also write the cost c as a function of n. Right? You could also write a function of n like this. This is okay too. If you wanted to do that instead. But the cost is a piecewise function, right? Because it's $5 per person. Write this off to the side. Let's leave this blank for now. Right? It's $5 per person. If we have 1, 2, 3, 4, up to 9 people. If the number of people is between 1 and 9, and it's just $50 flat, if we have at least 10 people. So this right here, these are our domain restrictions. They're domain clarifications, right? Those things right here tell us which piece to use. It's our domain, because n is our independent variable, kind of like our x. So how do we write this other part? Because actually this thing over here is already done. We can actually just copy that over. That's complete. N is between 1 and 9. And if n is at least 10, then we use that formula. It's always $50. There's nothing we have to plug in for n. If we have at least 10 people, it's always just $50. But this one is a rule. This one needs to write. This one has to do with the number of people n. So this one is $5 per every person, right? So if n equals 1, then it's 5. If n equals 2, it's 10. If n equals 3, there's $15 that we have to pay. It's going to be 5 times n. Like so. And this is our answer right here. This is a function relating the number of people n to the total cost c. Let's do a graphical problem. Sketch a graph of the function from example 5. That function was f of x equals either negative x, x squared, or x plus 1. And it was this if x was to the left of 2. It was this if x was between 2 and 0. And it was this if x was at least 0. So I'm not going to have you graph this by hand, but you can. What I'm actually going to have you do is graph it with Desmos, and then we might copy it down by hand, okay? So if we have something like this, we're going to make our graph, and we're going to copy it down from Desmos, okay? So let's go on to Desmos. And again, there are many links in Canvas, or you can just type in desmos.com. I don't know why this is glitching out a little bit, but it is. We did it. Okay. So desmos.com/calculator if you'd like. I like having things in reverse contrast, but you don't need to. So here's how you type this, a piecewise function, into Desmos. Okay. So there's 3 pieces, right? We're just going to type in each piece to start. Okay. So, oh dear, that's not what I wanted. Y equals, the first part was negative x. The next part was x squared. The next part, x plus 1. So these are all 3 of the pieces. But the problem, right, is that in a piecewise function, this is not a function. What we have drawn is not a function. Let's make them all blue. Let's you can hold down the click, hold down your mouse, make them all blue if you'd like. This is not a function. It fails the vertical line test. We need to only use this piece when x is less than negative 2. So what we're going to do is type a space bar, curly bracket, x is less than negative 2. And now notice, right, that now this is restricted. Let's do that for all of them. For the next one, curly bracket, this is negative 2 is less than or equal to, so we type the less than and then type the equal to, and that turns it into this, x, which is less than 0. Now see how that piece got restricted as well. And then the last piece is x plus 1. And that's going to be when x is greater than, then type the equal sign, 0 like this. And now this is a function. All right, now this is a function. And now there's some other fancy things that you can do if you really want to get into it. Like some of these should have closed circles, some of these are going to have open circles. But what we're going to do is we're actually just going to do those manually on our paper. Okay, so we're going to start by going back here and trying to copy this down. So let's start with the left piece. Start with the left piece right here. This is at the point the point negative 2, comma 2. That's here. Is this an open circle or a closed circle? It's that left piece. It's the first piece. It's the first piece. So it's going to be an open circle because negative 2 is not included on here. And then this is just the diagonal line. We'll just draw a diagonal line like so. That's the first piece. It gets an open circle. The second piece is this parabola right here. That starts at negative 2, comma 4. Is this an open circle or a closed circle? In this middle piece, when x is negative 2, that's included. There's an equal sign here. That's going to be a closed circle. And then it's a parabola shape down to the origin, right? It's a parabola shape down to here. We're going to draw a parabola. Not like that. We're going to try to draw a better parabola. And is this an open circle or a closed circle? That's the middle piece. And specifically, it's this middle piece at 0. Notice how it's a less than sign. It's not included. It's going to be an open circle. Now, the last piece. This is also another line, and it starts at 0, 1. 0, 1. And it's a line that goes diagonally, like so. Is this an open or a closed circle? 0, it's this piece, and 0 is included here, so it's going to be a closed circle. So this is how we can use Desmos to plot this graph. Now let's combine a whole bunch of stuff from earlier on in the class, right? Look back a couple pages, however many pages. We said that f of -3, when x is -3, the y value should be +3. Right? We said this earlier, f of -3 is +3. When the x value is -3, the y value is +3. Let's see if that's true. When x is -3, -3 is over here, the y value should be +3. Yep, that's on the graph. -3, +3 is on the graph. What else did we say? When x is -2, y is 4. When x is -2, y is 4. We'll look at when x is -2, what's the y coordinate here? We're on the graph up here. -2, 4 is on the graph. Again, it's not this point. This is an open circle. It's not included. And you can actually do this with all of these and check all of our answers and see that all of the points that we commented on are on the graph. These are the points that we found in example 5. Every single point is on the graph. That shows that we did both example 5 and example 7 correctly. Okay, so piecewise functions can be pretty tricky, but Desmos will help. Review and practice will help, and asking me questions will help too. So good luck, and bye-bye.